All right, everybody, welcome to the video here for lesson number 2. So for lesson number 2 in Unit 2, we learned how to take what we learned in lesson 1, which was simplifying rational expressions, and use that to multiply and divide rational expressions. It's essentially the same exact thing. So let's take a look at number 1a. So for number 1a, we got to start by factoring. So the first thing I notice is this first numerator has a GCF of 2. Which I can then divide out, leaving me with x squared minus 5x plus 6. So now I can say that first numerator becomes 2, x minus 3, x minus 2, x plus 2, x minus 2, 2 plus x, and 3 minus x. So the x minus 2 is reduced to 1. The x plus 2 is reduced to 1. Even though those are backwards of each other, they're still going to reduce to 1. And x minus 3, that's going to reduce to -1. That's an additive inverse. Really nothing left up top except for a 2 and a -1. So this answer is -2, where x is not equal to plus or minus 2 and 3. For part B, for that first parenthesis, the numerator is going to become a plus 3, a plus 3. The denominator is going to be a plus 3, a minus 3. GCF of 3, a minus 3, and then a plus 3 again. A plus 3 is reduced to 1, a plus 3 is reduced to 1, a minus 3 is reduced to 1. Nothing left here but a 3, and a can't be plus or minus 3. Remember, for those undefined values, we're just looking in the denominator. The next example is a division problem. Remember, for division, we're going to just flip the fraction after the division symbol and change to multiplication, and then we can go ahead and go about our business as normal. So d plus c squared plus d squared can't be factored. I know you really want to factor that because it looks like difference of two squares, but it's not. D squared minus dc becomes d minus c. And we get c plus d, c minus d for difference of two squares there. So that reduces to 1. D is reduced to a -1. Nothing left to do, so I'm left with -d divided by c squared plus d squared. Now let's talk about those undefined values. So for c plus d, I'm going to get a c cannot equal -d. And for c minus d, I'm going to get a c can't be positive d. So I got c can't be plus or minus d. In this original denominator, I know that d cannot be 0, and also d can't be c, which we've already said here. For c squared plus d squared, any value there works. So as long as c and d are both not 0 at the same time, this works. Okay, so I'm not even going to show an undefined value for that. So there's my answer. That would be too specific of an undefined value. For part D, I'm going to leave the 6x. I have a 4x minus 4 GCF. Change to multiplication. X plus 4, x minus 4, and 4x. X minus 4 is reduced. The x is reduced. And then we're going to be left with 6x plus 4 all over 16. Well, that's actually still reducible. 16 and the 6, well, that reduces by a factor of 2. So I could change that to 3 and 8. So my final answer is going to be 3x plus 4 over 8, where x cannot equal plus or minus 4 and 0. the reason why it's all three of those undefined values, I get a 4 here, I get a -4 here, and I get a 0 here. All of those are places where the fraction had a denominator at some point. Moving on. Part E, GCF of 3x, leaving us with x minus 2, 3x plus 1, times x 1 plus 3x, and x minus 2, x minus 2. These reduce to 1. These reduce to 1. I know those are opposites, but not additive inverses. They're just the same. So we're left with 3x squared in the numerator. And in the denominator, we're left with x minus 2. Write that better. Where x is not equal to plus or minus, or just positive 2, sorry, positive 2, a negative 1/3, and a 0. All right, here's another one of those ones with a negative exponent. Remember, all this -1 does is it creates a reciprocal. So I could just flip this first fraction. So I'm going to get x plus 2, x minus 2 over x minus 3. That's that first fraction flipped. I'm going to wind up having x minus 3, x plus 2 all over x minus 2. X minus 3s, whoops, I don't know what I did there. X minus 3s reduce, x minus 2s reduce. I have x plus 2 times itself, which is x plus 2 squared. And x cannot be 2, 3, and -2. Because at one point this was in the denominator when it was up here. There's your answer. G. G has a little bit more tough factoring that you might not be able to do like so quickly. All right, so looking at this first numerator, I see the AC method. So I'm figuring out what multiplies to make 60, -60, that adds to make -11. So that's going to wind up being, so it's going to be -15 and 4. So then when I factor that, I'm going to get 6x squared minus 15x plus 4x minus 10. Do my GCF thing. So I have a GCF of the first two terms of 3x, leaving us with 2x minus 5. And positive 2, leaving us with 2x minus 5. So that first numerator is going to become 3x plus 2, 2x minus 5. For that first denominator, I also again have that AC method, so I'm figuring out what multiplies to make -36 but adds to make -5. So that's going to be -9 and 4. So now I would do 6x squared minus 5x minus 9x minus 6. Do your GCF thing. It's 4x. So that would be 2x, leaving us with 3x minus 2, -3, leaving you with 3x. This would be a positive. There we go. So then we'd have the two factors of 2x minus 3 and 3x plus 2. GCF 2, 3 minus 2x, and another one of those AC method ones. Now for that AC method 1, I can reorder that if I want. So the multiplication, what multiplies to make 100, what adds to make negative 20. That would be negative 10 and negative 10. So I'd have 4x squared minus 10x minus 10x plus 25. I just reordered it so it looked better. So I have 2x, leaving me with 2x minus 5. I have negative 5, 2x minus 5. So now I'm going to have 2x minus 5 times 2x minus 5. So what reduces? This reduces with this for a value of 1. This reduces with this for a value of 1. This reduces with this inverse operation there, so it's a negative 1. So what am I left with? I'm left with a negative 2 divided by 2x minus 5, where x cannot be 3/2, negative 2/3, and positive 5/2. Part H. So part H, we have some more, again, just more challenging factoring here. Again, division. So we're going to change this and flip the second fraction. So the first numerator is kind of tough to factor, right? So I have 12 and 1. So what multiplies to make 12, but adds to make negative 7. So that's going to be negative 4, negative 3. So when I rewrite that, I'm going to wind up getting 12a squared minus not 7 minus 4ab minus 3ab plus b squared. I'm doing the same thing I would have done if the b wasn't even there, if it was just a 1. So what's my GCF here is 4a. That leaves me with 3a minus b. I'm going to have a negative b, which is going to leave me with 3a minus b also. So that first numerator is going to become 4a minus b and 3a minus b, all divided by 3a plus b, 3a minus b, difference of 2 squares, times another difference of 2 squares, 4a plus b and 4a minus b, and that's unfactorable other than a GCF of b, which is going to leave you with 3a plus b. Oh shoot, I forgot to flip. Let's flip. So GCF of b, 3a plus b, and difference of 2 squares, 4a plus b, 4a minus b. 4a minus b and 4a minus b reduced to 1. 3a plus b, 3a plus b reduced to 1. 3a minus b reduced to 1. So what am I left with? I'm left with b divided by 4a plus b, where? Undefined values. I'm going to get b cannot equal plus or minus 3a. If we solve for a, it's okay. It's the same thing. I'm going to get b can't be plus or minus 4a. I'm going to get that from these parentheses here. I'm going to get b cannot be 0. And I'm going to have a b can't be negative 3a here, which I also have my answer. So there are my undefined values. These are complex fractions, which are really just division problems. So if I rewrite this, the numerator is going to become x minus 2 over x plus 1, x minus 1. Change to multiplication, put the x minus 6 up top, and the x minus 2, x plus 2 on the bottom. X minus 2's reduce. Nothing else reduces. So I'm left with our answer of x minus 6 all over x plus 1, x minus 1, x plus 2, where x is not equal to plus or minus 1, plus or minus 2, and 6. Even though 6 is in a numerator here, at one point it was in a denominator. The next fraction, right, if I rewrite that, it's going to become x plus 3, x minus 1, all over x plus 4, x minus 1, times x plus 4, all over x plus 3, x minus 2. X plus 3 is reduced, x plus 4 is reduced, x minus 1 is reduced. There's nothing left up top except for 1s. So I'm left with 1 divided by x minus 2, where x cannot equal negative 4, negative 3, 1, or 2. Challenge question says, suppose that x is equal to this expression and y is equal to this expression, and all of these values make it undefined. Show that the value of x squared times y to the negative 2 does not depend on the value of t. What does that mean? So if I was to take this expression and square it, and this expression and flip it and square it, would the value of t matter? Now what that means is, when you simplify it, is the value of t left in the denominator? So if I do some factoring here, so I'm going to have this x term twice, so I'm going to have t plus 4, t minus 1, all over 3. This is going to become 3t squared minus 1, so that's going to become 3t plus 1, t minus 1. I'm going to have that twice, so I'm going to have t plus 4 again. I'm going to have t minus 1 again, and I'm going to have 3t plus 1, t minus 1. Well, if I do that, multiply that by this fraction flipped twice. Why is it flipped? Because it's a negative exponent, right? So I'm going to have a 2t squared minus t minus 2. So I'm going to have 2t minus 2 t plus 1. And I'm going to have a t plus 4 t minus 2. And I'm going to have that twice. 2t minus 2 because it's squared. And then we could see what reduces. T minus 1s, t minus 1s, t minus 2s, t minus 2s, t plus 4 with a t plus 4, t plus 4 with a t plus 4, t plus 1 with a t plus 1, t plus 1 with a t plus 1. Notice nothing is left here in the numerator except for 4. Nothing is left in the denominator except for 9. So what that means is the value of t will not affect the outcome. I'm not sure if that's an E effect or an A effect, but we'll just go with A there. Now, why doesn't it affect the outcome? Because if you plug in t, it's going to reduce away in all those different places and still come up with a fraction of 4/9. So for example, if you were to like to plug in t equals 6, it's going to come up with some answer that's going to reduce to 4/9. If you were to plug in t equals 20, it's going to come up with a totally different answer that would also reduce down to 4/9 because all of these expressions are eliminated away. And that's it. There's your homework. All right. So hopefully you were able to finish watching this video in class. If not, you can finish it at home. Good luck with the homework. See you all tomorrow.